All right, so good morning. This is good afternoon. This is Miss Robinson. Today we're going to be talking about atomic structure. These notes go into the next clean sheet of in your notebook, the interactive notebook. Remember to update your table of content as well. All right. So, what is an atom? So, an atom is going to be something that is classified by a man named Democritus, right here. And it is seen as the smallest unit of matter and its identity of a substance. Okay, so we have matter in our hair, and it's made up of atoms. We also have this little pen; it has atoms, and it also a pair of scissors or even staples. Okay, are all made up of different atoms, and they could be the same exact atoms. Um, but they are very different formations, but they're all made up of atoms. So this is what we consider the smallest unit of matter. All right, so the atomic structure. So when we look at the atomic structure, we have, I'm going to go through all of these little bits of pieces at one time so we can all think about it all at one time. So you have two regions. You have the nucleus, and then which is the center of the atom, and then we also have the electron cloud. Okay, so the nucleus contains um, the mass of an atom. So I want you to think of the nucleus just like a cell that we talked about last year. And so the nucleus, and this is the region right here in the center, and this has less space, less mass. We want to put it in those terms. The electron cloud right here surrounds the nucleus. That is a big thing. So that make sure that you draw this basically to the scale. So you can remember that is the electron cloud, and that's the region that surrounds the nucleus. So this is going to take up a lot of space because there's going to be a lot of room between this region and this region. From the nucleus outward, it's going to be tons of room. So it's going to be taken account for most of the space, but it's not going to have a lot of mass or anything like that. Okay? So you think of the nucleus in the terms of a pickup truck. Someone taking the biggest pickup truck that you've got, and that's your nucleus. Okay? The electrons in our nucleus that surround are like if I take that nucleus, okay, that truck, and I put a feather on it, on the truck. So I've measured the mass of the truck already, and I add the feather. It's so microscopic, it's going to maybe register, not its, it's going to add a little bit of mass, but not a ton of mass. All right. So we looked at inside the nucleus. We have 2 to 3 atomic particles. Okay. So in the nucleus, we have 2 to 3 subatomic particles. Don't let the word subatomic scare you. They're just referencing to the small little particles that make up the whole atom itself. Okay. So that 2 that we are going to deal with are the protons and the neutrons. Okay. So the protons have a positive charge, and the neutrons are neutral. They don't. They have no charge at all. Okay. So they have no charge. Okay. All right. So in the electrons we have the third subatomic particle outside the nucleus. So remember that for the test or quiz, that is the electron, and it has a negative charge. It really has no mass. Okay, so think back to the pickup truck and the feather example, that the truck is the nucleus in the middle, and the feather is the electrons that barely weigh anything. Okay, so the electron is a subatomic particle with a negative charge and relatively no mass. All right, so how do these particles react? So how do they interact with each other? So the protons and the neutrons are compact, okay? They're living very close together, and they take up most of the mass, and they're going to have a positive charge in that nucleus because I have a proton which is positive, and a neutron has no charge at all, so it's going to be a positive charge, okay? So the protons and neutrons are positively charged in the nucleus, okay? And that's the mass of the atom, okay? So then we've got the negatively charged electrons that have a small mass but a large amount of space inside of the nucleus. So we have a negative large amount of space outside the nucleus, okay? So the negatively charged electrons, they have a small mass, but they occupy a large volume outside of the nucleus, okay? So how do the subatomic particles balance each other out? So protons equal the number of electrons, okay? So if we have 20 protons that are present, 20 pluses, okay, and then 20 minuses, so if we have 20 pluses and we have 20 minuses, I'm sorry for the handwriting, they're going to cancel each other out, right? So they're going to cancel each other out. And so the overall charge is going to be neutral, okay? So because I got rid of the charges, they equal each other out. Neutrons have no charge, and therefore they don't have an effect on the overall charge of the atom. So neutrons have no charge. They equal the number of protons. They do not have to equal the number of protons or electrons, okay? But we have the protons and the electrons. They balance each other out, okay? That makes it neutral. So, all right, so how do we know the number of subatomic particles in an atom? So an atomic number is the number that indicates the number of protons in an atom. So when we look at the periodic table and we look at hydrogen, the atomic number is 1. So it has 1 proton, okay? So the atomic number is 1. So hydrogen has 1 proton, okay? So if carbon is the atomic number 6 on the periodic table, then the atomic number is 6, and it has 6 protons. If in your notes, I would definitely write these 2 examples down. So the number of protons identify the atom. And this is very, very important. So if the number is 1 in the hydrogen, 1 is telling me it's hydrogen, that number 1 is hydrogen, and it's specific only to hydrogen. If I had any other number, it wouldn't be carbon. Okay, so 2 protons is helium. Okay, in this example right here. If we had 29 protons, it would be copper. Okay. All right, so the subatomic particles in an atom. So how do we know the number? Well, the mass number. The mass is the number of protons and neutrons in the nucleus. Okay, it is the number of protons and neutrons in the nucleus. Okay, that gives you us the mass number, that decimal number. So, example: hydrogen can have a mass of 3. Since it has 1 proton, it must have 2 neutrons. So the number of neutrons equal the mass number minus the atomic number. Okay?